Hey guys, so in the previous video on multivariable optimization, I discussed example 17.10 of mathematics for economic analysis by Sater and Peter J. Hammond. And in this video, I'm going to start with exercise 17.4, question 1. And I'll try to cover question 2 also, but let's see. So let's just start now. So let's start now. Question. This is question 1 of multivariable optimization exercise 17.4, right? So let's start now. The question is, consider the function f defined for all x comma y by, so this is a function fx comma y given to us, which is x square plus 2xy square x square plus 2xy square plus 2y square. Compute the first and second order partial derivatives, first and second order partials of f. So we need to compute fx, fy, fxx, fyy. If I denote x as the first variable and y as the second variable, so I can write this as, we need to compute f1, which is fx, f2, which is fy, f11, which is fxx, and f22, which is fyy. First and second order partials of f. So I have discussed this in the previous videos also. So f1 is del f by del x, the partial derivative of f with respect to x. f2 is the partial derivative of f with respect to y. f11 is the second order partial derivative of f with respect to x, which is basically del f by del x. So the partial derivative of this function, which can also be written as del square f by del x square, del x whole square, right? And f22 is similarly del square f by del y whole square, which, if I write it again, can be written as, so this is, what is this? This is exactly equal to del by del f upon del y. Let me just move it here. I have discussed this in the previous video, so if you haven't watched any of my videos, please go and check them out. You will understand what I'm doing. I'm just writing the formulas again so that you guys can consider this as a mini revision and just start with solving the questions, right? And there are no conceptual gaps. So del upon del y, del f upon del y, right? So this is basically what we need to do. And we can also compute f12, which is equal to f21. So basically f12 and f21 is, f12 is del by del y and del by del f. So this is basically I am finding the partial derivative with respect to y of the partial derivative with respect to x, and f21 is equal to, so I can write this first. Let me just complete this. I can write this as del square f by del y into del x, and I can write f21 as del upon del x and del f upon del y. So the first order partial derivative, so basically I'm finding the partial derivative of f with respect to y. So this becomes again del square f upon del x into del y. And by Young's theorem, I can say that this expression, or just by looking at these expressions, you can see that this expression, this expression, well, let me just not draw a line. So basically this expression and this expression, they both are equal, right? So I can write it here. Let me just write it here. So f12 is equal to f21, which is equal to del square f upon del x del y, or del y del x, right? So this was part of our question. Now I am writing all of this again so that one more point that I need to add. Me writing all of this again will actually help you when you look for my PDF that I always attach in the description of my videos, right? So if you go to my description, you will find the link of my PDFs, and you can look them and revise using those PDFs, right? So if I write all of this stuff, when you open the PDF, you will find all of this written here, right? So while revising, it will help you a lot. That is one of my primary reasons that I insist myself and force myself to write all of this again. Now we need to solve. We need to find all of this, right? So this was our initial function. Let me just copy this. So this is duplicate, right? So now I'll just start solving. So fx fx is f1, because x is my first variable, so f1. So f1 will be del f by del x, which is basically 2x, which is 2x, 2x plus 2y square, right? And f11, which is del square f by del x whole square. This is equal to 2 plus 0, which is equal to 2, right? And similarly, if I try to find f2, which is del f by del y, this will be equal to 4xy plus 4y. And f22, which is del square f by del y whole square, is equal to 4x plus 4. Let me just see if I've made any mistake. 2x plus, yeah, this was my function, x square plus 2x, y square plus 2y square, 2x plus 2y square, 4xy plus 4y, 4x plus 4, right? Now let's just find f12 is equal to f21. Now I can use any of the definitions, right, to find this. Either I can use this and find the partial derivative of this function with respect to y, or I can use this function and find the partial derivative with respect to x. So I can use f12. So I'll be finding the partial derivative with respect to y using this function, so it will become f12. And if I use this definition f2, so I'll be finding the partial derivative with respect to x of f2, so it becomes f21. So I'll be showing you. I have discussed all of these concepts in the previous videos. Ideally, I should be just start solving all of the questions, and I shouldn't be explaining all of this again, but to insist, I have explained all of these concepts again, but I'm again writing and explaining you, so that when you open the PDF, you will find all of this, and it will be much easier to you, right? So let me just show you the first definition, F12. I'm using F12. So first of all, let's just use and show you F12. So F12 is F12. So basically del square F by, or let me just show you again. So del F upon del X was already given to me. Now I am finding the partial derivative of del F upon del X with respect to Y. So this becomes del square F by del Y and del X and del X. So this gives me F12. So F12 is del square F del Y del X, del square F del Y del X, yes. So this is the function. So I need to just find the partial derivative of this with respect to Y. So this will be 4Y. So del by del Y, and this was 2x plus 2y square, 2x plus 2y square, which gives me which gives me 4y. And F21 now. So F21 is del by del X with respect to del F by del Y. Now del by del X and del F by del Y was F2, which was 4xy plus 4y, 4xy plus 4y, 4xy plus 4y. Now the partial derivative of this with respect to x. So this will give me 4y plus 0, which is 4y. Hence we can see that my F12 and F21 have come out to be equal, which shows us that what we have done is absolutely correct. So I can just write it here as F12 is equal to F12 is equal to F12 is equal to F21, which is 4y, right? Now part B says that show that the stationary points are 0, 0 minus, show that the stationary points are 0, 0 minus 1, 1 comma minus 1 comma minus 1, and classify them So now I'll be finding the stationary points, and then I'll be classifying them. So for learning how I am classifying this and what theorems I am using and how I am using the Hessian matrix, you have to see the previous video. Again, I haven't explained Hessian matrix in depth at depth in my previous videos. So I want you to open the book and try to read about Hessian matrix first. Though Hessian matrix will come in your textbook later on in further exercises, but I have used it to classify some of the points that I have the connection between the Hessian matrix and this theorem, which is given in before exercise 17.4. I have explained the relation in the previous video, so do check that out and try to learn how I'm classifying. Otherwise, if you just see the theorem 17.5, which is given on page 633, so page 633, you can also learn how to classify these points from that, right? And I have discussed this theorem in the previous videos, so do check that out and then come here. So if I try to explain the classification again and again in all of the videos, then the video will become quite long, and the guys and the people who are watching this video regularly will lose interest. So that's why I'm not explaining this again, but do see the previous video and then come back to this video, and also do read the text. So my main point is to solve questions, a lot of questions, so that you learn how to solve. Once you know the process, once you have tried learning the process on your own and you have tried seeing my videos, you know how to structurally solve all of the questions. That is my main point of bringing all of these videos to you and creating this channel, right? Because there are a lot of great teachers out there on YouTube, different teachers who have taught optimization also, and have explained the theoretical concepts in depth. But my main point is to give you all of the solutions, because at many times we try and learn the theory and we try to grasp the concepts, but until and unless we start applying those concepts, there is no point of making us feel, assured that I know the concepts and I know multivariable optimization. Unless and until you know how to apply those concepts, you don't have proper knowledge of the subject, right? Show that the stationary points are 0, 0, minus 1, 1, minus 1, minus 1, 0, 0, minus 1, 1, and minus 1, minus 1, and classify them. So now we already have our partial derivatives, right? So f1 is 2x plus 2y whole square, 4xy plus, so I'll just erase this, right? I need to equate these partial derivatives to 0 to find the stationary points, right? So f1 is equal to 2x plus 2y square equal to 0, which gives me x plus y square equals to 0, and from here I can say that f2 is equal to 4xy plus 4y equals to 0, which gives me x plus 1 into y is equal to 0. So 4, if I just take 4y common, so x plus 1 and 4y, yes. So from here I can write the stationary points as, so if I just take this expression, I can have either x is equal to minus 1 or y is equal to 0. Now I'll be putting these points here in the first expression, right? And this will give me x plus y, right? So let now x is equal to minus 1, let x is equal to minus 1. So minus 1 plus y square is equal to 0. This means that y square is equal to 1. This implies that y is equal to plus minus 1. So the points that we have gotten from this is minus 1 comma 1 and minus 1 comma minus 1. Now we have in the second step we have y is equal to 0. So let y is equal to 0. Now I have x plus 0 whole square is equal to 0, which gives me x is equal to 0. So the point that we have is 0, 0. So three stationary points that we needed to find were 0, 0, minus 1, 1, and minus 1, minus 1. So 0, 0, minus 1, 1, and minus 1, minus 1. Right? So we have our stationary points. So we have 0, 0, we have minus 1, 1, and we have minus 1, minus 1. Three stationary points, right? Now what we can do is we need to classify them. For classification, I'll be creating the Hessian matrix. The Hessian matrix says that so I'll be drawing the Hessian matrix. So in Hessian matrix, what we need to do, we need to write the f11, f22, f12, and f21, right? So if you don't know about Hessian matrix and you start reading theorem 17.5, in order to know how I am using Hessian matrix here, you need to watch the previous video. But if I explain you again, this is A, this is C, and these two are B because these two are equal, right? Sorry, I need to just clear my throat. So this is A, this is C, this is B, and this is B. This is according to theorem 17.5, because in theorem 17.5 they have written A as f11, B as f12 and then C, and then they have given us a relationship between A, B and C, and then they have given us conditions how A and how the values of A, B and C help us classify all of those points, and then they have given us a process. So if you don't watch my video and just open theorem 17.5 and you try to watch this video, then so you would know how I'm applying those concepts and how those relationships that are defined in theorem 17.5 are the same that I am applying, but the difference is I'm using a Hessian matrix to do all of that. But do watch my video. So basically, now let me just remove this. Or let me just write this here. So f11 is A, f22 is C, f12, f21 is equal to B, right? Now let me come to my Hessian matrix. So this will be h of x comma y, and my f11 was f11 was 2, f11 was 2, f22 was 4x plus 4, so 2 and 4x plus 4, so 2 4x plus 4, and f12 is equal to f21 was 4y, I guess it was 4y, right? Yeah, so it was 4y, so 4y. Now I'll be using the different points. The first stationary point was 0, 0, so I'll be just substituting 0, 0 in place of x and y, right? So this will give me 2, 0, 0 and 4. So A, which is equal to 2, is greater than 0, C, which is equal to 4, is greater than 0, and B is equal to 0. So my AC minus B square, which is 8 minus 0 is equal to 8, which is positive. So my A is positive, my C is positive, and my AC minus B square is positive. This shows us that the Hessian matrix is positive definite, and my stationary point 0, 0 and 0, 0, my stationary point is 0, 0 is a local minima. Now if I use fx comma y again, so fx comma y was 2, and 4x plus 4, and this was 4y, and this was 4y, right? This was my Hessian matrix. Right? So this is my Hessian matrix. Now if I use my other point, which was minus 1 comma 1, right? Minus 1 comma 1 and minus 1 comma minus 1. Wait a minute, yeah. So minus 1 comma 1 will give me 2, and 4 minus 4 plus 4 gives me 0. So this becomes 0, and this is 4, and this is again 4, right? So 2 is positive and 0 is greater than equal to 0. My AC minus B square, so this is A and this is C, and my B is equal to 4. So my AC minus B square, or the determinant of this matrix, gives me AC minus B square. So 0 minus 16, which is minus 16. So my A is positive, but my AC minus B square is equal to negative 16, which is less than 0. So this is an indefinite matrix. Which implies that minus 1 comma 1 is a saddle point. And also remember one thumb rule: whenever AC minus B square turns out to be negative, we always classify that point as a saddle point, which means it is neither a maxima or a minima. From one angle it looks like a maxima, and from other angle it looks like a minima, right? Saddle point. Now if I move on, let's just classify our last point minus 1 which was 1 comma minus 1 comma minus 1, right? So it was minus 1 comma minus 1, minus 1 comma minus 1, minus 1, yeah, minus 1 comma 1, minus 1 comma minus 1, yes. So this gives me, now I'll be just directly substituting 2 and 4x plus 4. So this is again 0 and this is 4y, so this becomes minus 4 and this also becomes minus 4. So this becomes a is equal to 2 and c is equal to 0. This is c is equal to 0 and ac minus b square, b is equal to minus 4. ac minus b square becomes 0 minus 6 minus, this becomes 16. This is 16 and minus 16. Again this becomes 0 and this becomes 16, 16 minus 16. So this becomes 16 minus 16. Again I can say that minus 1 comma minus 1 is a saddle point and minus 16 is less than 0, so minus 1 comma minus 1 is saddle point. So if I just conclude my question, I can write a little statement here which concludes it, and I'll be writing this using a black pen. I'll write it in bold, and we don't need to find any other thing, right? Or let me just use a green pen here, right? So 0 comma 0 is a local minima. Minus 1 comma minus 1 and 1 comma minus 1, sorry, minus 1 comma minus 1 and minus 1 comma plus 1 are saddle points, which means neither a local maxima nor a local minima. So this is our final solution. So the video has become 25 minutes long. I guess I should end this video here only. Otherwise, if the videos are too long, people tend to procrastinate and not watch the whole video, or just watch the introduction part. So I don't want that. So I'll be leaving and ending this video here only, and I'll be coming back either next week or in 2 or 3 days, because this video was not that long and I think I can cover 2 or 3 questions more. I have an option of covering one more question here, but I'm leaving this video at 25 minutes only so that it becomes easier for you to watch, right? So thank you, and keep watching my videos. Do put in a comment. It would really encourage me to go on and bring more concepts to you. And if you want to share anything, if you want to ask anything, if you want to tell me to make videos on some specific topic, please do let me know. And if you want me to cover some concepts quickly because your exams are coming up or something else, so I'll be putting in the solutions from other exercises also, right? So please share my video, do like the video, please put in a comment, and do subscribe the channel. It helps me and motivates me to keep coming again with new energy and keep bringing in these amazing concepts for you, right? So thank you so much. Bye bye.